So projectiles, horizontal plane, type 4, clearing a wall. So here we have in 1998, a football is kicked from a spot on level ground and it has a velocity of root 8 g meters per second, striking a vertical wall 4 meters away at a point 2 meters above the ground. And again, we want to find two possible angles of projection. So again, if we do a little sketch so we can see what's happening. So it's kicked from the ground, which is level, and we don't know what the angle is, so our angle of projection is going to be alpha. It has an initial velocity of root 8g, and that's meters per second. And then what we have is our projectile path striking a wall, and the height at which it strikes the wall is 2 meters. So in other words, this is S in the y direction. And then we're told the wall is 4 meters away from where it was kicked. So again, this is our range, or S in the x direction. Okay, so let's make out our table based on what we know. So we have U, A, V, S and T. And you're going to complete the table by pausing the video and checking if you've completed the table correct in our x and our y direction. So we have to remember that U is going to be U cos alpha in the I direction and U sine alpha in the j direction. So U is going to be root 8g. So that's root 8g cos alpha for x, root 8g sine alpha in the y direction. Our initial velocity, our acceleration due to gravity is going to be 0 in the x direction and minus g in the y direction. So again, because our initial velocity is in the upward direction and gravity is in the opposite direction, we've assigned u to be positive and therefore g has to be negative. V in the x direction then will be root 8g cos alpha, and then 0 times t will be 0. V in the y direction is going to be root 8g sine alpha minus gt. S is ut plus a half at squared. So therefore S in the x direction is root 8g cos alpha t, and in the y direction root ag sine alpha t minus a half gt squared, and then t for our time. Okay, so to find our two possible angles of projection, well, we have to use the information that we know. So basically we can work out our time of flight and then use that in our second equation. So what are our two pieces of information that we have? Well, we're not using sy equals 0 this time because it's striking the wall. So it's easier to start with when striking the wall, we know that our range is going to be 4 meters. This is an easier equation than to get our time of flight. So we can see root 8g cos alpha t is going to equal 4 meters. So therefore t will equal 4 over root 8g cos alpha. And now we can use this then for the second piece of information we have, which is where it strikes the wall. So when striking the wall, it hits the wall 4 meters above the ground. So in other words, sy is 2 meters. So we said that sy then was root 8g sine alpha t minus a half gt squared. So we're going to now let that equal to 2 and sub in our time of flight. So always be careful that you're squaring your time here. And that equals 2. Okay, so for simplifying here, we're going to have root HE goes into root HE once. Sine alpha over cos alpha we know is tan alpha. So that's times 4. So that's going to be 4 tan alpha. And then I'm going to have minus a half times g. So in other words, g over 2. And if I square my brackets there, we end up with 4 squared, which is 16, over root 8g to be squared, which is 8g, and cos alpha squared is cos squared alpha, and that equals 2. So simplifying there, then we can see g goes into g, 8 goes into 16 twice, so therefore that goes into 2 divides into the 2 as well. And then we're left with 1 over cos squared alpha. So you have to remember again your trig, right? Projectiles has a lot of trig in it, hence I love it. Favorite topic. So we have 1 over cos squared alpha, and we have to remember that 1 over cos squared alpha is basically sec squared alpha, but of course sec squared alpha is equal to 1 plus tan squared alpha. And again, all of that can be found on page 13 of your maths tables. So spotting that then allows us to create a quadratic equation in terms of tan. So we're going to have minus 1 plus tan squared alpha equals 2. So getting rid of those brackets, we have 4 tan alpha minus 1 minus tan squared alpha, and let's bring it over that 2, so that's minus 2 equals 0. So that, if I multiply everything across by minus 1, leaves me with tan squared alpha minus 4 tan alpha plus 3 is equal to 0. Okay, so we have 4 tan alpha minus 3 minus tan squared alpha, and then multiply across by minus 1, and we now have a lovely quadratic to solve. So what are our factors of 3 that are going to add to give us minus 4? Well, it must be minus 3 and minus 1. So if I sub back in, we have tan squared alpha minus tan alpha minus 3 tan alpha plus 3. And again, remember, it doesn't matter which order you put those 2 values back in there for 4 tan alpha. They can be neither. And we're going to group the first 2 to get the highest common factor, and group the second 2 and take out the highest common factor. So therefore we have tan alpha is common, leaving us with tan alpha minus 1. Minus 3 is common, leaving us with tan alpha minus 1. We then have tan alpha minus 1 is common, so highest common factor each time, leaving us with tan alpha minus 3 equals 0. So if 2 factors multiply to give us 0, that means that one of the factors must be 0 or both must be equal to 0. And therefore that allows us then to get tan alpha on its own. So tan alpha equals 1 or tan alpha equals 3. So let's go back to the question. So it doesn't say find the 2 possible values of tan alpha. It actually says find the 2 possible angles of projection. So therefore we need to get alpha on its own. So therefore if I get alpha is equal to tan inverse of 1, well, we know that one off by heart. Tan inverse of 1 is, of course, 45 degrees. So again, you can get that on page 13 of your maths tables. Or if you're using your calculators, please make sure that you have your calculators in degrees here. And of course, then the second value is where I get tan inverse of 3, which obviously can't be found in your table, so you have to use your calculator for that. And that's 71.56 degrees. So our 2 values for alpha. Okay.